Hello friends, I am Sils and in today's sections, especially for class 10 it is, chapter 1 part 4 it is. So today we are going to discuss about center of gravity and how to calculate center of gravity for different rigid bodies of regular shape and also irregular shape one. Then about the concept of circular motion, uniform circular motion. Clear? So first one is center of gravity. Center of gravity. What is center of gravity? So we know that it's a point or a particular body on which the entire weight of the body is concentrated, isn't it? So that one we can consider. We know that solids. Let's consider a solid. The rigid solid we are considering. We know the solids are made up of particles, isn't it? And particle has got a fixed position when compared with the other ones. So all these particles has got a particular weight. Like one particle of a solid is composed of a W, a small letter W weight is there. Okay. So this is the weight of particle or a solid. Likewise, n number of particles are present on that solid. Clear? So definitely the total weight of the body will be n W. That's called as the total weight W. And now consider each particle will have a weight W, and that will act in the downward direction due to the gravitational force. Okay. So all these weights will act downward. They are parallel to each other. The following this one due to the gravity. Clear? So n number of particles are there, and then definitely n number of W's weight will be there. They will act in the downward direction, and all these forces will be parallel to each other. It will act in the downward direction due to the gravity. And in such a manner, there will be one point, and from where the total resultant weight will act in the downward direction, and that point on the body is called center of gravity. So in a definition we can say that center of gravity is a point on the rigid body or the solid on which the entire weight of the body is concentrated. Clear? So that's the concept of center of gravity. The point on the body on which the whole weight of the body is concentrated is called center of gravity. In that manner we can define center of mass also. Center of mass means the point on the body on which the entire mass of the body is composed, which means concentrated. So that particular case is center of mass. So center of gravity is the one where the total weight W is acting in the downward direction. That is the center of gravity. And how to calculate, how to determine the center of gravity of different bodies? That's our next aim. So for that, let's consider the case of regular bodies. Okay, regular shape. What is a regular shape? Which means they have definite shape. Borders will be there, definite shape will be there, and their densities will be uniform throughout. Okay, and how to calculate their center of gravity? First of all, we can consider rectangular one or a parallelogram one. Okay, for the case of rectangular and parallelogram, we can consider the center of gravity as the point in which the diagonals are missing. The point which means the intersection point of the diagonals will give you the center of gravity for the case of rectangular shape and also for the case of parallelogram. And the second case, that is a triangle. If it is a triangular lambda, then the center of gravity can be determined with the help of medians from the three vertices, and definitely they will intersect at a particular point, and that point will be the center of gravity for that triangular line. Clear? The intersection point of the medians. Then third case, that is for the case of a cylinder. We know that cylinder, there will be a central axis will be there, it is passing through the center of the two circular portions of the cylinder, and the midpoint of this particular axis will be the center of gravity. Then for a circular shape, you can say that the center of the circle will be the center of gravity. Clear? So that's the case of a regular shape. Regular shape means a fixed boundaries are there, fixed shape is there, and their concentration is uniform, and these are uniform throughout. That type of bodies, we can find the center of gravity by using this concept. By intersection points of diagonals will give you the parallelogram and rectangular body center of gravity, and for the triangular lambda it will be the intersection point of the medians, and the midpoint of the axis will give you the center of gravity for the cylindrical case, and for circular it will be the center of the circle. So that about the regular shaped bodies. Okay. Then how we calculate the center of gravity for irregular one, isn't it? That's our second topic. For irregular shape, we have to do some experiments for finding this particular center of gravity. Just consider we have a body of a shape like this. It's a regular one. There is no fixed shape for this particular body. So that is they are irregular in nature. Okay. So for this case, we can consider the center of gravity by using an experimental manner. So for that, we can make some points 1, 2, 3, 4, 5. Like this, we make some holes on that particular body, and with the help of a string, we can hang this body on a particular platform on different points. Clear? So you just use a thread, and that one you just hang. So when you hang this one, after some time it will come to an equilibrium state, which means it will not make any type of movement, and that manner you can draw a line fraction there. Same manner, if you take the point 2, definitely there will be another line of action will be there, and if it is 3, then if you hang it on the 3, then you will get a line like this. Then if it is hanged on the number 4, then definitely there also a particular line will be there. Then for 5, the hanging point, which means the 5 is placed here, definitely there will be also, you can draw a line which is keeping the body in state. So there you can see all these lines, when you hang this body in different points, will constantly intersect at a particular point, and that will be the center of gravity for the case of irregular ones. Okay, so this is an experimental manner. So using that one, we can find the center of gravity for irregular shaped bodies. Then there can be one question there. See, if center of gravity can take place only inside the body, there is nothing in that. It can take place outside also. Like the case of boomerang or L-shaped bodies, definitely the center of gravity will come and outside. Or the case of ring, in the case of ring, the center of gravity is coming inside that particular ring, which means the center. Circular shape, because of center will be the point in which the whole weight of the body will be concentrated. So that manner, in case of boomerang, for example, L shape. So all the you can see from this point, like this, we can consider median from here, like this, from this point it will be like this. So there will be one point in which all the lines will basically intersect each other, and that will be the center of gravity. Here you can see it is outside. The point of center of gravity is outside this particular boomerang. So there is no, we can't say that it will take place always inside the body, it can take place outside also. Clear? So that's about center of gravity. Center of gravity is the point on that particular body or solid in which the entire weight of the body is concentrated. Clear? So on the basis of center of gravity, now we are moving to the most important section, that is uniform circular motion. Until now we have discussed about the translational motion concept and all of things. Now we are moving to the case of circular motion. So for that you can consider a stone which is connected with a string or something like that. Okay. So and we are wearing it on our hand. So we can see that the stone will make a circular path. So if I draw it that particular case, let's consider a stone of mass. Yeah, let's call it as mass M. It is connected with the thread or we have center. And using this one, we are rolling this particular stone, and it will make a circular motion around that particular point O. So here you can see the direction of the stone will be in this direction, which means it will be in the north direction. And after some time, it will reach us on this particular point, where the direction of the stone will be in east direction. Okay, here it is on north direction, here it is in the eastern direction. So you can see the direction of the stone change after some time. Clear? So that's one thing, you just keep it in mind. So you can see when you rotate a stone, it will cover equal distance in equal interval of time, which means it has got a uniform speed. But you can see the direction of that particular stone is varying, isn't it? The direction on this particular point is northern, and when it reaches here, It seems to be in eastern direction. See here? So even the body is covering equal distance in equal interval of time, its direction is changing, which means it has got a variable velocity. Such type of motions are called uniform circular motion. A particular motion, a body is moving in a circular manner, covering equal distance in equal interval, which means a constant, a uniform speed with a variable velocity. Variable velocity, there is no change in the magnitude, only the change is in direction. Clear? Which means that due to that change in direction, definitely it will get an acceleration. There is no change in the magnitude, so it will be uniform accelerated motion. Clear? So such a motion is called uniform circular motion. Okay? A body is covering equal distance equal to time around a particular point O, which is having uniform speed but variable velocity, which means it is changing its direction, and in such a manner it will get an acceleration that will be uniform because magnitude is not changing, only direction is changing. Clear? So that particular motion is called circular motion. Now we can compare this uniform linear motion and uniform circular motion. Linear motion. So now we can check the changes between difference between uniform linear motion and uniform circular motion. Okay. So what is uniform linear motion? That you are familiar with. Uniform linear motion, a body is moving in a straight line. Isn't it? Transversal motion is taking place, covering equal distance in equal interval of time. So on that basis, first one speed. For the case of a uniform linear motion, the speed of the body will remain constant. Same time for the uniform circular motion, then also we know that it will cover equal distance in equal interval of time, so the speed is remaining constant here. Then what about velocity? So in uniform linear motion, the translation of only one direction is there, so there is no change in direction. So definitely velocity is a constant quantity for linear motion concept. And when you come to the case of uniform circular motion, we told that we have seen that the direction of the body is changing every point. So the velocity seems to be a variable quantity. So it is variable. Now the third one is acceleration. What about acceleration? So if the body has got same speed and same velocity, then definitely the acceleration will be zero there, isn't it? So acceleration on the case of uniform linear motion will be zero. No acceleration will be there. Same by uniform circular motion. It's a variable velocity, but its magnitude is same. Only it is changing the direction, so it will have an acceleration which is uniform. Uniform acceleration will be there. Clear? Then, for the case of uniform linear motion, there is no need of any external force. It can continue in the state without any external force, without the force. So there is no external force is required. So no external force in the case of uniform linear motion. But in the case of uniform circular motion, we know that it's a uniform accelerated motion, which means in all manner it is changing its direction. So in order to change the direction, there is a requirement of force. A force is required for the change in its direction. So force is required. An external force. External force is required for uniform circular motion. So these are the main difference between uniform linear motion and uniform circular motion. First one, speed is constant for both the cases, but velocity is variable for uniform circular motion because it is changing its direction in all points, in each point. At the same time, acceleration is zero because velocity and speed is constant here, and for uniform circular motion it will have a uniform acceleration because velocity is not changing its magnitude, only direction is changing. Then external force is required for that change, so in uniform circular motion external force is required. Okay, so these are the difference between uniform linear motion and uniform circular motion. Now I told you in the case of circular motion, you can see a stone is covering equal distance equal over time, which means it has got a constant speed, but its velocity is variable, isn't it? It's a varying concept, which means it is changing its directions at each point. Clear? So magnitude is not varying, but even though the direction is changing, we know that according to Newton's first law, a body cannot simply change its direction by itself. So if it wants to change the direction, definitely there is a process of an external force. It requires an external force. And in this case, for the case of uniform circular motion, there will be a force And that force is the reason both constituting this change in direction. And there one more specialty is there, that is it must change only the direction. There must be no change in the magnitude of force. You follow this way? And such a type of force is called centripetal force. The centripetal force comes in action in the case of uniform circular motion, and the specialty of that force, it will make changes only in the direction of that particular motion. It will not make any type of changes in the magnitude. And such a force will always take place right angle to the direction, and which will act always to the center. So centripetal force is a force on a circular body which acts towards the center of the circular path, and which will always right angle to the direction, which is not changes the magnitude, which will changes only the direction. So that is centripetal force. So which can be represented by the letter Fc, which is equal to mv square by r, where m is the mass and v is the velocity, r is the radius of the circular path. So this is centripetal force which is acting towards the center. So in connection with this centripetal force, we can bring the Newton's third law, that is every action has an equal and opposite reaction. The same we can say that if a force acts in this inverted direction, there must be a force which will act as a reaction force in the opposite direction, and that force is called centrifugal force. Centrifugal force, and this force is acting away from the center of the circular path, and magnitude they are equal but their direction is opposite to each other. Clear? So both have the same magnitude but they are acting in the opposite direction. So this is centripetal force and this is centrifugal force. Now we can check the difference between centripetal force and centrifugal force. We can say centripetal force is acting in inverted direction to the center, whereas centrifugal is acting away from the center. Clear? And also one more thing, they are acting on different bodies. We can't say they are acting on the same body, they are acting on different bodies. You can see when you are welding a stone in your hand with a thread, definitely on stone there will be a centripetal force which acts towards the center. At the same time in your hand you will experience the centrifugal force which acts away from the center of that particular part. Clear? So both this force, centripetal force and centrifugal force, will take place on different bodies, not on the same body, different bodies, and they are equal in magnitude and opposite to the opposite in direction. Clear? So this is the case of uniform circular motion. Uniform circular motion covering equal distance in equal interval of time with a variable velocity, and that variable velocity comes only in case of direction. There is no change in its magnitude, and that is due to the effect of the centripetal force, and an acceleration will be there, and that acceleration is called centripetal acceleration. AC we are representing. Due to that centripetal acceleration, the force is called centripetal force. You can calculate that as mv square by r, and there is a reaction pair is there, that is centrifugal force, that will act away from the center of the circular path. Clear? So that's all about this uniform circular motion, centripetal force and centrifugal force. So I think you may clear about these particular portions. Today this portion we have discussed about center of gravity, how to calculate center of gravity of bodies, then uniform circular motion, especially centripetal force, centrifugal force, the difference between centripetal and centrifugal force. So that's all about this chapter 1. So hopefully I will catch you with some exercise portions and coming into this particular chapter in the next class. Till then, bye.